Hello. Just another update on the rudder servo and the autopilot box that I'm getting close to getting into a workable state now on the boat. Well, I've just brought the boat into my study so that I can connect it up to my PC and see what's going on. It's quite cramped in here. We've got the boat there and the electronics up there. So here we have the main electronic box that's going to go above the deck, which I've almost finished wiring up. Looks a bit of a mess at the moment. I've temporarily taken out this power pack so that I can power it off my lab bench power supply. Some of these wires are just to take serial lines out so that I can see what's going on, and it's been pointed out to me that other more sophisticated and sensible people actually use Bluetooth to communicate between their box and an external PC, and that would probably be a much more sensible thing to do, but I didn't have the brains to do that at the time. So we've got two serial lines going into the PC down there, and then the data comes up on these screens. The way this works at the moment is that we've got a helmsman loop in this micromite here, which generates a PWM rudder signal, which comes out on this grey wire and goes into this box here, which contains a model radio controller and a relay. It goes through the relay and back, and then down the black wire to an Arduino in the rudder servo. The Arduino measures the width of the PWM signal and converts it back into degrees, and then drives the rudder. The point of this arrangement is that by operating the radio control I can change over the PWM signal from removing the signal from the autopilot and substituting a signal from the radio control, so that we can sail the boat by radio control if we want to. And when we don't want to use that, I can just put a dummy plug in here which bridges the PWM signal across here, and we don't need this box. So if I turn this on, first thing that's going to happen is that the servo will calibrate itself by moving the rudder to -70 and +70 degrees, and then back to the center. And then in a few seconds the autopilot will take over, and because we're trying to steer a course of 20 degrees and it's actually on a course of 315 degrees at the moment, it starts with a rudder signal of 40 degrees to starboard. So if we then move the boat in response to that, of course the steering signal will go down until eventually, if we get on course, it should go down to about 0, as you can see there. We'll put it back to that. You notice that the rudder is moving in jerks. This is because I've got a deadband built into the algorithm here, because I don't want small variations in PWM signals to be constantly fiddling with the rudder. That deadband is adjustable. The other thing I can do is, if we want to control the rudder by radio control instead, I can switch the radio control on, and now I have full control of it. And we can switch it back to autopilot like that. switch it back to radio control like that. If you move the control quickly, it will make a continuous movement, but if you move it slowly, because there's also a timing loop in this, I think it's paying attention to the signal once a second, and that's also adjustable. We need to experiment with this in the water to see what's really desirable, but it's a compromise between smooth continuous control on the one hand and not chewing up an enormous amount of battery power on the other. You'll see that the total current consumption is 138 milliamps at the moment. About 35 milliamps of that is in this radio control thing, which isn't important because we're not going to have it there on a real mission. About 60 milliamps of that is this GPS unit, which we don't need to turn on. So we could take 90 milliamps off that, and then we get down to 40 milliamps, which is still more than we really want, but I'm going to have to look into the budget on that. I can also turn the compass off under software control, but I don't think I'm going to be allowed to, because Dick really wants the helmsman loop to operate continuously, and that requires the compass to be on all the time. So what I have to do now, on this screen here I've got telemetry data coming from the autopilot directly over a serial line, but it's supposed to be going into this connector and up the mast to a LoRa transmitter. So that's what I've got to wire up next, and when I've done that, this will be ready to work in the real world. One of the things the Micromite does is it outputs a PWM signal to control the rudder, but it also reads that signal back just before it goes to the servo box and displays it. The point of that is if the PWM signal to the rudder is actually coming from the radio control, then we still get the rudder angle in the telemetry output. But looking at it, I can see that the PWM signal that a Micromite reads back is not always exactly the same as the signal it's supposedly outputting. And that is also true of the signal read by the Arduino in the servo box. Both of these reads are being done by a pulse-in function, which seems to be somewhat inaccurate. And I may need to look into doing that a better way. But for the moment, I'm putting up with it as it is. I did check with an oscilloscope that the width of the pulses output by the Micromite is exactly correct. So there's not a problem on the output side. That's all for now. I'm waiting for a plug to arrive before I can connect up that LoRa telemetry connection to the box, because I ordered the wrong one and the wrong crimp terminals and so on, so I had to send them back. But hopefully the next update we shall actually have a boat in one piece with everything ready to go. Thanks for watching.